Hello mathematicians, welcome to the corner of the internet called Marshable Math. My name is Mr. Marsh. Today we're going to be discussing how do you write an equation of a line from knowing a point and a slope. So recall, there are two different ways to express the equation of a line. The first one here is y is equal to mx plus b. That's called the slope-intercept form because the m value is the slope of the line and the b value is the y-intercept. Remember, that's where it crosses the y-axis. The y and the x here, those are the point values that can lie on the line, any one of those points. This equation right here is either called general or standard form, and it's ax plus by is equal to c. Has to be written in that order. The x's and the y's on the left, x comes first, the c on the other side of the equal sign. But notice that the a and the b and the c are capital letters. That tells us that the values here that we're multiplying a, b, and c, those have to be integers. In other words, they have to be positive or negative whole numbers, except for the a. The a value there, the value on x, usually has to be positive. So the a has to be a positive integer, but b and the c, those can be negative if the case allows for it. And also remember that the slope being the rate of change, it's the change in the y value over the change in the x value. Here's our classic slope formula. y2 minus y1 over x2 minus x1. And remember, we get slope of the line from 2 points, and the subscripts here, 2 and 1, just tells us whether we're talking about the y values from the first point or the y values from the second point. So forth for the x's. So now the question would be this. If I know that the line goes through the point, 1, 3, and has a slope of 5, how do I write an equation that would express that line, either in slope-intercept form or in standard form? Here's what we're going to do. We're going to take this relationship right here for slope, and we're going to use this then to construct our equation. So let me rewrite this down. Slope, m, is equal to y2 minus y1 over x2 minus x1. But remember, we only have 1 point. So actually there isn't a second x and y value. There isn't a second point. We're going to be talking about those x and y values in general. So I don't need the subscript here of 2 because there isn't a second point. The y and the x value here are simply going to be the y and the x that show up in the equation. I don't know what those are. Those could be any number of different ones. So we're going to drop the subscripts, and now I've got the slope, which is 5. I've got my x and y values from my point, which is 1 and 3. Let me just substitute those in now and do some algebra, and we'll have the equation. So slope, substitute in, that's 5. It equals the y of the equation minus the y point value, that would be 3, divided by x of the equation minus the x of the point value, which would be negative 1. Let me clean this up a little bit. We get 5 is equal to y minus 3 divided by x plus 1. And now I've got to decide which one of these lines here, which one of these forms I want to use. Let me start with this one first. This is probably the one that gets used the most, the slope-intercept form. So I'm kind of out of room here on the bottom. Let me come up to the top here. So if I multiply both sides by x plus 1, so multiply this by x plus 1, multiply this side here by x plus 1, this is going to cancel. And what I would get would be 5 times x plus 1 is equal to y minus 3. Now let's distribute that across. 5x plus 5 is equal to y minus 3. My goal is to get y by itself. I got one step to do that. Here's my y. Y minus 3, let me add 3 to both sides of the equation, and I would get 5x plus 8 is equal to y. That's almost the same as this one here. Notice that the mx and the b are on opposite sides, so let me just spin the whole equation around. Just transfer everything, and I would say then y is equal to 5x plus 8. There's my equation in slope-intercept form. From that, I can grab off of here, well, my slope was 5. Of course, I knew that, right? I told you that right there. And also my b value, or maybe the c value, if you call it that, but it's not the same thing. B value, my y-intercept is 8. Well, let's actually see if this works. You don't always have to do this, but I just want to confirm with you what we're talking about here graphically. If my point is negative 1, 3, negative 1, up 1, 2, 3, this is the point. that I'm starting with. And my slope now is 5. So that means that my change in the y over the change in the x is going to be equal to 5 over 1. So that means up 5, 1 to the right. So up 1, 2, 3, 4, 5, and then 1 to the right gives us the next point. Let me draw that line there. It should look like that just by plotting the point and doing the slope. The question now is, okay, is my y-intercept 8? Should be, according to my equation here. Let's take a look. The y-intercept is going to be up 1, 2, 3, 4, 5, 6, 7. Looky there. Y-intercept of 8. There it is. Okay. So remember, what we're doing is we're taking this equation right here from the slope. We're substituting in the point values for y1 and x1, substituting in the slope value for m, and then we're solving it. What if though I wanted this one? What if I wanted ax plus by is equal to c? I could either take this equation right here and subtract 5 from both sides and then multiply through by a -1, or maybe I could just move the y to the right and then move the 8 over. But we could also simplify it from the get-go. Let me back up a bit. Let me just start from here. If I wanted the standard form, again, let me simplify. 5 is equal to y minus 3 over x plus 1. Remember, if I multiply both sides here by x plus 1, I would get 5 times x plus 1 is equal to y minus 3. This would be 5x plus 5 is equal to y minus 3. Now let me just move the y over by subtracting y from both sides, but also let me subtract 5 from both sides. Minus 5 minus y. What I would get would be 5x minus y is equal to -8. That would be then in standard form or in general form. Notice that all of my coefficients here are integers, they're whole numbers, and the a value, the value on x here, is positive. The x and the y are on the left, and the c value is over there on the right. Okay? But usually, kind of most of the time when I'm doing the algebra with students and when we use it to do graphing and things like this, this is the one that we want. But you need to know how to work it into the different form if possible. So let me give you one to try now. Let me give you the following. So if the point is 6, -2, and the slope is -3 over 4, I'm giving you fractions. Try to figure out the slope of the line here in a slope-intercept form. I'm sorry, figure out the equation of the line in slope-intercept form. Okay? So go ahead and press pause in the video, take a moment or two, do your algebra work, come up with an answer, box it because you've got to commit, and then press play again, and we'll see if you and I get the same thing. Ready? Go. No, seriously, you got to do it. Go ahead, go. Okay, here's what I'm going to do. What's my equation? My equation is going to be slope then is equal to the y of the equation minus the y value of the point over x of the equation minus the x value of the point. Let me substitute in now the values. So slope is going to be -3. 4 is equal to y minus -2 over x minus 6. For simplicity's sake right here, I won't take a separate line to do this. A negative times a negative is a positive, right? So I can do that. You can't do that on paper, but I have my special skills here on the whiteboard. So now, how do I solve this then? I want to solve it for y. Notice I've actually got a proportion here, right? Remember, how do you solve proportions? You set the cross products equal to each other. Maybe in 6th grade they told you something simplistic like cross multiply, but what we're going to do is we're going to set the cross products equal to each other. So let me do the y on the left because that's how I want it to show up over here. I'm going to take 4 times this group. Remember, these are quantities. So it's 4 times y plus 2 must be equal then to -3 times x minus 6. Okay? come up here because I'm out of room. So this is now going to be 4y plus 8 equals negative 3x plus 18. With me so far? Okay, move the 8 over. 4y is equal to negative 3x. How did I move the 8? I subtracted it from both sides. So plus 18 minus 8 would be plus 10. And then I need to divide everything by 4. But remember here, remember that whatever you do to one side of the equation, you must do to the entire other side. I hope that's not too high in the video. I hope you can see that there. Remember? Because if we divide this side by 4, we have to divide everything over here by 4. Not just the 3x and not just the 10, the whole thing. So what I'm going to get then is y is equal to negative 3/4 x plus 10/4. What is that? That's like a fraction. Maybe you could make it 5 halves, 2.5, something like that. Let's go ahead. Since we have a fraction here, let's leave that as 5/2. That would be the equation of our line and slope intercept form. Let's graph it, see what we get. 6, negative 2. I hope I got room over here. 1, 2, 3, 4, 5, 6, and then negative 2. All right, so I got that there. Now, the slope says negative 3/4. Remember, slope is the change in the y over the change in the x. So negative 3/4 means to go down 3, right 4. But I'm out of room. How do I do that? Oh no! But it doesn't matter where we put the negative, right? I can put the negative with the y value, or I can put it with the x value, provided it's not both, right? Provided it's just one. So this means, oh, I can go up 3 and left 4. Let's do that instead. So up, 1, 2, 3, left, 1, 2, 3, 4. If I've done that correctly, up 1, 2, 3, 1, 2, 3, 4. That should be it. Okay, should look something like that. Let's check our y-intercept here. Up, plus 5 halves. What's that, 2.5? Oh, looky there. Plus 5 halves. Yay, works. Okay? So don't be scared of fractions. You're the fraction master. You know how to handle them. All right, so from this point right here, if I wanted to put it in standard form, well, actually from this point right here, if I wanted to put this in standard form, I would then move the x to the left and then move the plus 8 to the right, and then I would have it in standard form. Let me do that just real quick if you got the time, which I'm sure you do. From right here, I would move the 3x to the left by adding 3. So I would get 3x plus 4y is equal to, and I would move the 8 to the right by subtracting 8. What would that be, like 10? But there it is in standard form, or general form. Okay, same equation, just different form. What happens if you rearrange all these things and you get something over there on the left-hand side with the next that's got a negative? Oh no, negative 5x, plus 6y is equal to negative 17. I just made that up. Don't think that it's related to any of this stuff. Okay? How would you change that? All you got to do is just multiply both sides by negative 1, and you've got your answer then. That would be 5x minus 6y is equal to positive 17. Just make sure that in the end that your coefficient on the x is a positive value. All right? Now, this is a very, very good form. Although, remember, it comes from this one right here. That's not the form that I regularly use, though. If you like doing the fraction thing, that's fine. This proportion here is very usable. You can get the work done there. But the one that I tend to use the most is actually called point slope form, and it's simply this. If I just simply multiply both sides of the equation by x minus x1, move this over here to the left, then what I get is I get y minus y1 is equal to m times x minus x1. That's the one that I really like the most. Okay? Because if I want an equation of a line, all I do then is I just substitute in the point values for x and y, substitute in the slope, and then I can simplify it. So for this one then, it would be y minus y1, so that would wind up being y minus negative 2 is equal to the slope, negative 3/4, and then x minus the x value, x minus 6. And if you do the algebra on that right there, it's ready to go. Okay? I hope you learned something. Remember that mathematics isn't just for mathematicians. Mathematics is a human endeavor. So if you're a human being, mathematics is for you too. Have a great day.